Hello students, welcome back to Standard 7 Mathematics class. We are doing lesson number 5, Operations on Rational Numbers. Today we continue with practice set number 22.
Now let's see the subtraction of rational numbers. If the rational numbers are having the same denominator, the steps are the same, only instead of addition you have to subtract the numerators. So we move on to numbers having different denominators. Again, I have taken examples from your problem set. Question number 2. The question is 7 upon 11 minus 3 upon 7. Now here again both are having different denominators. So first we have to equalize the denominator. So what we have to do? Multiply the first fraction by the denominator of the second and multiply the second fraction by the denominator of the first. Multiply both the denominator and the numerator. So this doesn't change the value of the number. So when you multiply, you get 7 multiplied by 7 upon 11 into 7 minus 3 multiplied by 11 upon 7 multiplied by 11. So what you will get? You will get 7 multiplied by 7 is 49 upon 77 minus 3 multiplied by 11 is 33 upon 7 multiplied by 11 again 77. In addition, you were adding the numerators. Now you have to subtract the numerators. The denominators are the same. So you will get 49 minus 33 upon 77. That's equal to how much? It's equal to 16 upon 77. Now let's try the fourth bit. The question is 4 and 1 by 2 minus 3 and 1 by 3. So first what we have to do? We have to convert the mixed number into an improper fraction and then carry out the subtraction steps. So first let's do that. So you get 4 multiplied by 2 plus 1 upon 2 minus 3 multiplied by 3 plus 1 upon 3. You have to multiply in this manner. So you get 4 multiplied by 2 is 8. 8 plus 1, 9. So you get 9 upon 2 minus 3 3s are 9 plus 1 is 10. So you get 10 upon 3. Now we make the denominators equal. So you get 9 into 3 upon 2 into 3 minus 10 into 2 upon 3 into 2. Multiplying the first fraction by 3 and the second fraction by 2. So you get 27 upon 6 minus 20 upon 6. So you get 27 minus 20 upon 6. That's equal to 7 upon 6. So the answer is 7 upon 6. Now let us see how to multiply the rational numbers. It's question number 3 from the problem set. We will try the first bit. The question is 3 upon 11 multiplied by 2 upon 5. Now when you multiply fractions, all you have to do is multiply the numerator and multiply the denominator. So what will be the answer? So in this case it will be 3 multiplied by 2 upon 11 multiplied by 5. So what will be the answer? 6 upon 55. Now let's try bit number 3. The question is minus 8 upon 9 into 3 upon 4. Now if you see 8 is a multiple of 4 and again 9 is also a multiple of 3. So let's try to reduce it. 4 1 time and 4 2 time, 3 1 time and 3 3 times. So the answer is minus 2 upon 3. So if there are common factors while multiplying, you can reduce it to the lowest term. Please solve all the questions in your notebook. Now you can try out question number 1, 2 and 3 of practice set number 22.
Let us see what is meant by multiplicative inverse. The multiplicative inverse of a number is a number which when multiplied with the original number is equal to 1. It is also called as reciprocal of the number. When you multiply two numbers, if the answer is 1, then each number is called a multiplicative inverse of the other. Please note, the multiplicative inverse of 1 is 1 only because you know that 1 into 1 is 1. And also, the multiplicative inverse of 0 does not exist. This is because 1 divided by 0 is undefined, or division by 0 is undefined.
I have the numbers 5 by 6 and 6 upon 5. If you multiply the two, what answer will I get? The answer I get is 1. So these two numbers 5 upon 6 and 6 upon 5 are called multiplicative inverses of each other. Let's take another example. If I multiply minus 7 upon 2 and minus 2 upon 7, the answer is again 1. So the multiplicative inverse of minus 7 upon 2 is minus 2 upon 7. Now dividing a rational number means multiplying by the inverse of the second number. Let's take an example. I'm continuing with practice set number 22, question number 5. The first question, 40 upon 12 divided by 10 upon 4. When you're dividing by a rational number, all you got to do is multiply by the inverse of the second number. So this becomes 40 upon 12 multiplied by the inverse of the second number. Inverse of this number, 10 upon 4, will be 4 upon 10. You only have to invert the numerator and denominator. Now, if you are able to cancel out, you can cancel 10 one time and 10 four times. And 4 one time and 4 three times are 12. So you get 4 into 1, that is 4, upon 3 into 1, that is 3. So the answer is 4 upon 3. Let's try another question. Question number 2. The question is minus 10 upon 11 divided by minus 11 upon 10. The first number remains as it is, minus 10 upon 11. The division becomes multiplication and you have to invert the second number. You have to write the multiplicative inverse of the second number. So it becomes minus 10 upon 11. Always remember, the sign never changes. If it is plus, the inverse also will be positive. If it is minus, the inverse also will be minus. Now, multiplication. So you get minus 10 into minus 10 upon 11 into 11. Minus multiplied by minus is plus. 10 into 10 is 100. So you get 100 upon 11 into 11 is 121. So you get 100 upon 121. Now let's try the fourth bit. The question is 2 upon 3 divided by minus 4. So 2 upon 3 multiplied by the multiplicative inverse of minus 4. The multiplicative inverse of minus 4 is minus 1 upon 4. Because this is as good as minus 4 upon 1. So the inverse will become minus 1 upon 4. So let's read 2 one time and 2 two times. So you get 1 into 1, 1. So minus 1 upon 3 into 2 is 6. So the answer will be minus 1 upon 6. You can try the remaining sums as homework.
Now let's consider this table, which is on page number 35 of your textbook. Here you have to consider the group of natural numbers, integers and rational numbers. Now in front of each group, write the inference that you make after carrying out the operation of addition, subtraction, multiplication and division using a tick mark or a cross mark. Remember, you cannot divide by 0. If a natural number is added, the sum is always a natural number. So we put a tick mark under addition in front of the group of natural numbers. Now, if you subtract one natural number from another, the answer is not always a natural number. That is, take the example 7 minus 10. 7 minus 10, the answer is minus 3. And minus 3 is not a natural number. So under subtraction, we put a cross mark. Now, multiplication. 7 multiplied by 10 is 70. So when you multiply natural numbers, the answer is also a natural number. Whereas in the case of division, when you divide two numbers, the answer need not be a natural number. So we put a cross mark here. Similarly, we check for integers. When you add two integers, the answer is always an integer. Same way, when you subtract two integers, the answer is always an integer. Multiplication of integers, also the answer is an integer, but this is not true in the case of division. In the case of rational numbers, we see that the addition, subtraction, multiplication, and division, the answers are also rational numbers. From the previous table, we come to the conclusion that the group of natural numbers is closed for addition and multiplication, but not for the subtraction and division. In other words, the difference of any two natural numbers or the quotient obtained on dividing one natural number by another will not always be natural number. The group of integers is closed for addition, subtraction, and multiplication, but not for division. And the group of rational numbers is closed for all operations: addition, subtraction, multiplication, and division. However, we cannot divide by 0. Please complete the remaining questions of practice set 22. Thank you. Stay home. Stay safe.